And thank you, Rajiv. We are very pleased to be working with our partner agency, the New York State Pollution Prevention Institute. Our organization, the Toxic Use Reduction Institute in Massachusetts, is very similar to the New York State Pollution Prevention Institute, in fact. We're located at UMass Lowell, and we were established by the Toxic Use Reduction Act of 1989. So we've been in business now almost 25 years. And our role is to make Massachusetts a safer place to live and work, as you see from our tagline there. And we do this through a number of programs. We work quite extensively with a variety of different industries, providing training and other services. One of the key aspects of what we are responsible for doing in Massachusetts is training toxic use reduction planners. Toxic use reduction planners, or TERPs as we sometimes call them, work with industries to assist them in finding alternatives to the use of toxic substances that enable them to continue to do what they do and continue to do it profitably, but do it with less resource use and with less use of toxic substances. In addition to training, we have a very extensive lab that is able to provide services to companies on things such as solvent cleaning, disinfection, janitorial cleaning, and metal finishing alternatives. And because we're here at a research university, we have a lot of resources from which we can draw to assist companies in doing what they need to do. We also sponsor academic research. We sponsor grants to industries and community groups, again, all around looking to try to reduce the use of toxic substances. And finally, we assist our state legislature, as well as the federal government and even international agencies, in developing policies for the reduction of toxics in a variety of situations. So that's about our two organizations. I'm going to turn it over now. We had planned to start with Marco Duffy, but Marco is having trouble getting logged on here. So, Chris, I hope I'm not tripping you up too bad by asking you to start. Let me just tell you about our two speakers. Chris Capalbo is going to be starting off here. Is the VP of Operations for New Method Plating. It's a metal finishing and plating company in Worcester, Massachusetts. It's a family-owned company that's been in business since the 1930s. And Chris has grown up with this business. He has been very, very active over a number of years with the North American Metal Finishing Association, both regionally and nationally with that organization. Marco Duffy, who will come on later, has also had a long association with the metal finishing industry and has also been very, very active in the metal finishing trade organizations, serving as an officer both nationally and in the Northeast region. So these are two people with long and real hands-on experience with the metal finishing industry. Not only have they been great exemplars of new advances in environmentalism in this important industry, but we've had the pleasure here at Torrey to work with them over a number of years in doing demonstrations and trainings and so on. So with that, I'd like to turn it over now to Chris Capalbo. And as soon as we get him unmuted here, we will give him the opportunity to show his slides.
Hello.
So Chris, you're on, and let me just get you on here, and you can take it away, Chris.
Okay. Can you see my screen, Mark?
Yes, Chris, you're on the air, and we can see you over the webinar.
Okay, great. I appreciate it, Mark. I appreciate all your introductory comments. Yeah, what I want to speak about specifically is more so of a case study that would pertain to what we do and the experiences that we have. Marco is going to talk a little more generally speaking about different chemistries, different ways the metal finishing industry has developed and used different technologies to meet the lower costs and green expectations and different marketplace-driven expectations in the industry. Hold on one second. So first of all, a majority of what we do here, we do a lot of military, Department of Defense, and aerospace work. And one of the main driven things in these industries is cadmium-plated parts. So as a lot of you may know, cadmium is, while it has extremely good properties, that is desired and mandated by these different military and Department of Defense industries. They have a lot of good things, like I have here on the slide, that make it very easy to plate, to use from a metal finishing standpoint, and its properties are what they are desiring. What it is not is an environmentally friendly finish that over decades now has come under scrutiny for various different reasons. So over the time, it has all but disappeared in commercial use, worldwide use, but still has a very prevalent purpose in our world, specifically our country, for protecting lives, all sorts of things that have to do with our government. These are some of the different uses that it specifically has. The NADCAP accreditation process was put in years ago, which I won't get too much into, but it is something that this type of plating falls under, along with many other ones. But what it is an accreditation program designed by aerospace and defense contractors, and one of the things that they, of course, desire is the cadmium plating. Of course, cadmium plating has chromates, and the chromates specifically that are used are hexavalent chromates. There's no good alternatives right now that are designed to work over cadmium plating, like the trivalent chromates. It is not RoHS compliant, and RoHS is something that you'll probably hear quite a bit throughout the whole presentation. The RoHS is the restriction of use of certain hazardous substances, which was a standard that was put in by the European Union quite some time ago now, that started slow and, over the years has gained a lot of momentum and is becoming very prevalent. And what it does is it restricts the use of substances overseas in various countries. It's very specific. It's very complicated. It has a lot of different working parts to it. One of the big things nowadays, of course, is trivalent chromates. Getting rid of hexavalent chromates to use trivalent chromates. These are just some of the different problems I touched upon with cadmium plating. All sorts of things that, like I said before, these are things that you want to drive out as a business owner, as somebody who needs to meet environmental standards. It costs money. While the cost of using the finish is not all that costly, it has a lot of other downsides at the other end that could make it costly. They do make it costly, i.e. getting the chemicals, the treatment of it, the accreditation processes you need for it. Like I say on the bottom slide here, the U.S. government, the biggest user of this, yet they're the ones that make it the hardest to use. And by hardest, I mean the most regulations and the strictest regulations on it. So what you get into then, specifically, if I'm just talking about cadmium plating right now, is alternatives. Well, the alternatives over the years have come about, they haven't really gained any momentum. And the reason is it's very difficult to find good alternatives to this specific plating. I'm not talking about other platings, because like what Marco will talk about, there are a lot of good alternatives to different plating baths, technologies, equipment. A lot of those things have come a long way, and a lot of those things have been very beneficial for lowering your cost of production, reducing human health risks, competing with positioning overseas for demand from customers who insist on this green technology now and green finishes. Just talking about cadmium plating right now, there's no really good alternatives that have been developed. So it's a problem. It's a problem moving forward. What do you do? How do you do it? This is military government work. These people are not willing to take risk that could fail. So these things take a long time. Commercial work is different. If you had hexavalent chromates on top of any kind, a fastener that goes into a desk or something like that, these things aren't catastrophic failure. You're not talking about things like that. I'm not saying they should be taken lightly, but the alternatives have developed to a point where why wouldn't you use it? It doesn't make any sense to stay. It's just like anything, to stay with your old technology just to stay with it because it's easier, par for the course, that kind of stuff. It doesn't make a lot of sense nowadays. As a business owner, you want to keep moving forward. You want to lower your costs. And yeah, there are certainly some expenses that go into it when you're turning the corner and you have to develop these new technologies. But having seen it over decades now, I've seen a lot of these technologies have come a long way. I mean, I can honestly say that not only cost, but use, easier to train your employees, easier to run, easier to maintain. So they have come a long way. So there gets to a certain point where as a metal finisher, supplier, it's your duty. You have to do these things. You have to push this new technology because it is better, and it does have good properties, and it does have good use, and there is a point to it. There is an end means to it. That not just, oh, I'm just changing just to change. No, there's just changing because these things are better for the environment, better for the world. These are all things that, as we all know, looking decades down the road, who knows what our world's going to be like. We don't know, where we're going to be at environmentally. And small things like this have to keep gaining momentum and moving forward, and everyone has to be on board. And whether it started with the European Union and RoHS, that's good. It's good. It's a good place to start. It's going to take a long time for it to totally gain momentum, keep moving forward, keep fine-tuning it. At first, it was a very complicated, convoluted thing that nobody understood. I remember however many years ago now being in Washington, D.C., going to a conference about RoHS. At first, anybody had ever heard of it. And everyone's rolling their eyes. What is this? This is a nightmare. Numbers all over the place, and this and that, and how do you figure it out, and where does it start, and who's involved, and but it has developed, and it's taken a long time, but it's making more sense now, and it's making its way into big end users to a point where, okay, now it's trickling down the line, and it has a purpose, and a good purpose, because of the fact that a lot of these technologies have developed. So just got off track there a little bit, but that's basically kind of what is the point of my whole presentation. The CAD plating is something we do. We do a lot of it. We constantly are looking into ways to move forward with it. It's a good finish. We've done a lot of testing to come up with different technologies that could mimic it, be just like it, be in line with it. I can assure you we're a long way away from It is what it is. I mean, it's an extremely durable, pointful finish, and unfortunately, it has negative things that go with it, properties that go with it. So, you know, one of the types of finish is a common one, something that has changed, or zinc-plated parts with trivalent yellow chromate. This is a well-known finish around the world, and talking about this specifically, has come a long way. The old way of running zinc-plated baths were cyanide, hexavalent chromates, and it worked. Now you move forward, and it has taken a long time. They were extremely difficult to run from a business standpoint, from a production standpoint. They have become leaps and bounds. Now, zinc plating, like I said, is just a very general plating in the entire industry. So it's something almost every plater can probably relate to one way or another. It's inexpensive, sacrificial coating, not considered highly toxic. Moderate appearance, excellent abrasion resistant, paint adhesion, has a lot of good uses. Automotive uses it constantly, hardware fasteners. Almost every one of us in our lives have zinc plated parts somewhere in our lives, whether it's our automobile, our house, our desks, our bikes, our motorcycles, you name it. It's used worldwide, so it has a lot of specs to it that you can work, spec work, good on all types of base metals. So this is a good point. This is a good example of how moving forward with different chromates are very pointful, are there. They're there for you to use. You can use them. Yes, you can use hexavalent chromates, but you can also use trivalent chromates with good success. And I guess one of the things I should mention is, which is important when you're dealing with metal finishing. Metal finishing is measured in terms of salt spray use. It's a common thing that's used in the industry. It's basically how they determine parts to failure, which means the parts are put in a accelerated environmental chamber, which is what a salt spray chamber is, to see how long it can last until failure. And this is important, of course, about how parts react to being out in the real world. Chrysler or Buick or Ford doesn't want a screw that's going to go into their chassis that fails after 5 hours of salt spray. It would be a disaster. It would be all sorts of problems. So these are extremely important things, and this is where the trivalent and the hexavalent chromates come in. The baths themselves, which like I said, Marco is going to talk about a little more. The baths themselves have come a long way. You can use alternate chemicals that you don't have to use. There's a zinc cyanide bath, for example, was a very popular bath way back in the day, and I know people still use them now. There's not a lot of point to using them now. From everything, from a cost perspective, from a health risk perspective, nobody wants to have cyanide in their building. It's a very pointful chemical. It has a lot of good to it, believe it or not. I know people hear that word and they think it's the worst thing in the world. It isn't. Just like a lot of things in this world, it's very harmful to you, can be. Move on from it. There are other things that are much better. Then you get onto the chromates. Hexavalent chromates are extremely good chromates. They have a lot of good properties to them. No, we wouldn't use them if they didn't have good properties to them. I think people need to remember that when it comes to dealing with these different chemicals that are on these lists. Yes, they have been proven to be on some level hazardous, to whatever. I mean, there's been research on it. There's been debate on them, back and forth, a lot of good and bad. That's just like anything. Debates, and everybody's got their own opinion. So the hexavalent chromates have a lot of good properties. So, and now, or what they over the years have been tried to develop is a trivalent chromate that will mimic the hexavalent chromate's properties, their positive properties, without the negative properties. So to do that, unfortunately, this is where it's a little bit, just speaking of chromates, top coats, different chromates that go strict anodizing, chromating goes right over aluminum. We don't do that here, but I know a little bit about it and how it works. It's the same ideas. You need to get into trivalent chromates with top coats, and a lot of time these things are great. They work well. The biggest problem from a business standpoint is the cost of these things, and it probably for the foreseeable future will be. It's fine, just like anything. I need to charge X for this part. I have top coats. I have these things all add up. They're not cheap chemistries. They're new chemistries. They're new technology, and just like anything new, it can be expensive. So try to work that into the cost of your work. You pass it on to your customer, just like it works in any manufacturing in the entire world. You pass the cost down, and it works its way down to what the cost of the final product is. Problem is that we live in a society now, a world, that is very competitive. We have a lot of overseas competition, and a lot of that overseas competition runs, drives the cost of the price down. So where do you stop? How do you price these parts? I need to charge you 50 cents a piece for these parts. Well, I can get it done for 25 cents overseas. I can't do it for that price. I can't run my business with this price. How do you compete with that? Now, you want to use the new technology. You want to use the environmentally friendly, the RoHS compliant. You want to compete. How do you do that? I can run my hexavalent chromate bath at 25 cents a piece. I can run my trivalent at 50 cents a piece. How do you do it? Where do you find that balance? Are there ways that you can save money other places, i.e. waste treatment? Sure. I mean, that's another big expense in our industry. Waste treatment overhead is an expensive part of running a business, a metal finishing business. It's a worthwhile investment. It's part of your business. It should be part of every metal finishing business, an important part. Just like anything, it takes resources. It takes money. It takes a lot of upkeep. It takes, you have to stay up with technology. So it all has to do with the pricing of these parts. So yeah, it's one of the problems. How do you face that problem? Getting back to zinc plating problems, it's an inexpensive use. Because of it, people might say, hey, just use zinc plating to replace cadmium. It doesn't work that way. It's not that simple. It sounds good. This is part of the sticking point. Instead of just saying, hey, okay, we don't want to use cadmium plating anymore. It's hazardous. It's this. It's that. Let's just try something else. That's what they're doing. That's what the military's doing. The aerospace industry, Department of Defense. They're constantly trying to do R&D on new technologies to replace. Easier said than done. I can assure you, we've done a lot of R&D on it. We've done a lot of testing. It's getting there. It'll take time, which is good. It's good to keep moving forward, trying to come up with new ideas. Maybe go a different direction than what they're going in now. Ultimately, it comes down to the military, DOD, aerospace, are not willing to risk the use of these in the field right now because they're not there. They're not at the point where you can feel 100% comfortable with protecting the lives of our troops, our citizens, our everything, because ultimately what all those departments have in common is that there are lives involved. And so it's a very fine line of just jumping forward to wanting to meet green expectations in the marketplace and just doing it, okay?
So Chris, I think in the interest of time, I'd like to be able to move on to Marco, if that's all right.
Yes,
and
absolutely.
Give ourselves a bit of time at the end of the session for questions.
Yes, absolutely.
And I'd like to just make it clear to all of our participants listening in. All of you are muted, but we do encourage questions for either Chris here or Marco. And you have a chat function. If you expand the control panel that you have with the Go to Training or Go to Meeting control panel, you will see down at the bottom there that you do have a chat function. If you would like to pose a question to either of our presenters, please type your question in there, and I will be the one to pose those questions live to our presenters here. So with that, I'd like to go back to Marco Duffy, and apologize here. I need to get back to my own control panel. There it is. And,
am I here?
And yes, Marco, there you are.
Are we sure I'm here?
We're
I was having a Twilight Zone moment. I'm on the phone saying hello, hello, and nobody can hear me. So it was an existential moment there. If there's a webinar and nobody can hear me, do I really exist? So.
I will be, because Marco is on the road today. I'm going to be doing his slides for him. But Marco, you're there with your very first slide. Go right ahead.
All right, great. Well, I appreciate that, and I apologize for the technical difficulties. Not only am I on the road today, I'm on the road every day. But I really wanted to participate in this because I think it's something that's very important, and it means a lot to me. I have been involved in plating for a long time. I have run a couple of shops where I had profit and loss responsibility, as well as the responsibility for safety and quality and environmental, and when a lot falls on your shoulders, you're always looking for that better way. So what I wanted to do is kind of share where I've come from and talk about getting the value out of improving your environmental performance. And if you go to my second slide, I have defined value. And to me, the definition of value is dollars. And where, how and where can we improve our environmental performance and bring value to the company and either drive costs down or improve quality, which will reduce price, cost unto itself, or, deal with some waste treatment or employee exposure limits so that we get good value. And improved environmental performance was one area that I really thought that we could make and did make a lot of improvement. So if we go to the next slide, the sources of environmental improvement that can bring value, I've thought of these. And the first one was new processes. And what we'll find is that there are a lot of new processes that are better, cheaper, faster, and greener. And I put a couple of examples as trichrome passivates and cad and lead-free electroless nickel. That's two areas where the technology has caught up to the need. Even the automotive folks are saying, hey, the trichrome passivates are as good as what we used to use with the hex. We can accomplish what we need to accomplish. Right now, cad-free, lead-free nickel is the majority of the electroless nickel that I sell. And what we found is that with a lot of things, volume is everything. The prices have come down as the volume has gone up. So we're finding that we can run cad-free, lead-free electroless at the same price or perhaps even cheaper than some of the older processes that we're not making as much of. And, Chris brought up an interesting point a few minutes ago about the cyanide zinc. And I didn't even write that down because, to me, problem solved. We don't offer environmental. I don't talk to people about about cyanide zinc, because we have great drop-in replacements. They're easy. They run fantastic. In some cases, they get better throw. In some cases, they're brighter. And in every case, we have a lot less environmental concerns. We don't have 5,000 gallons of cyanide sitting in the shop. So a lot of times those new processes can offer you a lot of value. The other one is elimination of older processes. We put in these newer processes. We do create new opportunities. It might be quality improvements or safety improvements, and obviously wastewater treatment savings. If we're not treating hex chrome going down the drain, we're saving money. So we can eliminate the older processes, get those out of the shop, and still meet all of the specifications that we need to meet. The next one is wastewater treatment technology. When we bring in new wastewater treatment technology, a lot of times we find out we can reduce costs. And maybe we can reduce cost in a few ways by not having to drum something up and send it out, by recycling water and being able to reuse rinse water in some cases so that we're not paying to both, you pay by the water and send it down the drain. And the other thing is that I find with new wastewater treatment technology is it has a smaller footprint. So we save some money there, because when we have more areas in the shop that we can do production and make money as opposed to treat something and spend money, there's obviously a great value in that. And the last thing is, what I found is whenever we put in these newer processes, the environmental performance goes up, but we need to bring our platers up too. So I'm going to talk about training a little bit more as we move on. If you go to the next slide, here's a big opportunity that I have found and implemented myself in shops, the elimination of vapor degreasers. It really does. To me, in some cases, you absolutely positively have to have it, but in most of my job shops, we don't need to have them, and we can remove that expensive process for the shop. The last drum of solvent I bought, and it was probably 8 years ago, for a vapor degreaser, it was well over $2,000, and it didn't last as long as you wish it did. So we no longer have to buy that if we can eliminate the vapor degreaser. The other thing is, when we were able to implement utilizing our existing cleaning lines more, because the vapor degreaser was kind of the easy way. We just go in the vapor degreaser, then you can clean them anyway, and then we'll go down the line. Well, you know what? If we work a little harder, if we work a little smarter, we can use the lines we have. And we don't even have to turn that vapor degreaser on. The next thing is, and I thought about this specifically, because when I was able to wean everybody off of the vapor degreaser, and after 6 months, it became a great place to put your gloves, your apron, and your used coffee cup. We got it out of there, and it opened up a whole lot of space on the floor, because generally they're pretty big in a big production facility, and they're always in a key spot right at the front of the line, right? So we were able to get rid of that, the vapor degreaser, move the equipment out of there, and open up that floor space for more production, more parts that were racked up and ready to be run. So, and lastly, we got rid of it. We didn't have drums of solvent that every 6 months, at the worst possible time, when cash flow was at the absolute worst, we had to send it out. So we were able to save on that end as well, not having to send it out for treatment. And I did put a note. It's not always possible, because there are certain parts, certain applications, certain specifications that make you have to use it. But if you don't have to use it, by all means, don't. You'll find that you can do a lot of things without it in most applications. So, and then on the next slide, my other biggie is training. The newer processes, I tell folks all the time, if you're going to put in cad-free, lead-free electrose nickel and you haven't put it in before, I need you to do 2 things. I need you to tell all the platers that they have to be better. That their cleaning is going to have to be a little bit more careful. They're going to have to rinse a little bit better. They're going to have to do things like check for water break, because the newer processes typically aren't as robust. Same thing when we switched away from cyanide zinc. All of a sudden we found out that, everybody's cleaning lines were grossly inadequate. Cyanide zinc, very forgiving. You could forget to clean a part, put it in there, and it would play fine. When you put in an alkaline zinc or an acid zinc, you have to be a little bit better. You have to make sure that your cleaning is done better, that your platers are doing what they're supposed to do, frankly, what they should be doing. And what this means is that they're not just dipping things, running up and down lines, putting stuff in there because they were told to do. They're not dippers. They're not dunkers. They have to know what they're doing. They have to do a good job checking for water break, rinsing really well, flushing out blind holes, doing all those things. So the operators become better platers when you do this, and hopefully that translates across the shop, that you are now doing an overall better job, having fewer rejects, saving some money, because you changed something to improve your environmental performance that was a rising tide that lifted all the ships in your shop, that everybody became a little bit better of a plater because of that. And of course, the same thing goes for your lab. You have to have a good lab. You have to have a good, strong program where you're analyzing things on the right schedule, doing the things, again, that you're supposed to do. Not that we're giving you extra things to do. These are probably things that you should have been doing all along anyway. So if the lab is doing their job, and they usually do, and they want to do a good job, and you can apply some statistical analysis to this so that you're analyzing at the right frequency, you can, again, not only will you improve the performance of your newer, cleaner, greener technology, but all of your baths. Everything, your cleaners, your acid treatments are all going to improve because you've raised the level of awareness and the skill set of your platers and your lab people. And, you also, to do this, generally you need your supplier. And that doesn't mean he needs to be there to run parts, but he needs to do some training. He needs to make sure that he helps you, or she helps you, get into your shop and make sure that all your guys, from your lab to your operators to your rackers, know what the impact is, know what they need to do, and understand what this process's limitations may or may not be. So overall, you raise the tide of all of these areas, and you can do a better job. And once you've done a good job internally, if we go to the next slide, you'll see that externally you can be viewed pretty well and also. So, there's good public relations in adding these processes. And when you share that with your customers, they like it. They like to know that their plater is green. They like to know. They don't want to charge. They don't want to pay anymore, but they certainly want to know that they're getting the best, the latest technology available, that they don't have any concerns, and typically that their customers don't have any concerns. So your customers' like it when you're green. And it makes a big difference because somebody at some point is going to ask. And then naturally your employees, your neighbors, your friends are all going to like it if you run a nice green business. You share that with them, and it helps them to feel like they're working with or working near or next door to a company that's forward-thinking and doing a good job. And then, the trade magazines like it if you are green, but only if you tell them. So if you implement something and it's different and it's new and it's exciting, you know what? You should let folks know that. Put it in a trade magazine. Have them put it in as a news release. If you call the editor, they'll help you do it. Put it in a news release. Do some reprints. Send it out to your customers. Put it on your website. Make sure that the world knows that you've implemented something green, and that's a very good thing for you. And your supplier likes it if you're green because you know what? We're going to tell other folks. We're going to say, hey, you know what? We can do this. We've seen it done. We have a shop that's doing this now, and they'll share it with other people. And then sometimes you get OEMs calling suppliers saying, hey, who offers this particular finish because I need to get away from whatever it is that we're trying to get away from, whether it's hex, chrome, or cad, or lead, or something like that. So they'll sometimes share that, and they feel really good about it, and you can go home and you can tell your kids and you can put something on the refrigerator that says you're a greener company because that's what's most important, right? No. What's most important is leads to sales. If you do it right, if you blow your own horn, it will lead to sales. Sales leads to dollars, and that's another value that you will get out of improving your environmental performance. And that's a big deal. That's why we're all here, right, to make money. So going to the next slide, lastly, change is coming. You can resist it. You can do whatever you want. You can say it'll never happen. I remember 25, 30 years ago, the guys in the shop screaming, how will we ever plate without cyanide? And you know what? Somehow we're all still in business. So this change is coming. How hard do you really want it to be? And by that, I mean when your biggest customer calls and asks, sometimes they call and they say, hey, you're doing cad-free, lead-free, right? Or you took hex-chrome out of that process, right? And you say, well, no, you never told me I needed to. I don't understand. Why are you asking me now? And what happens is they say, well, our biggest customer told us that on May 1st they no longer accept cad, lead, hex, chrome, or any non-row house or ELV compliant finish. So now you get 2 weeks. And that's plenty of time to implement a change like that, right? You could train your guys, tweak your equipment, clean your system, neutralize any hex chrome. You could do all that in 2 weeks. And if you do it in 2 weeks, I'm sure that's the cheapest way, because you won't, you won't rush to buy the first piece of equipment that you can get your hands on. You'll shop it around because you have all that time. So, doing it the hard way is really, really difficult. And I recommend that you do it before somebody makes you do it, somebody asks you to do it, somebody tells you you have to do it. Do it when you can do it and it fits your shop. Because the easiest way, if you go to the next slide, is much cheaper and it is easier. You call your favorite supplier. I'll give you my number. You can ask for info to be sent. You can schedule a meeting. You can meet as a team with your supplier and your staff. You can sit down. You can talk about it. You can get the buy-in so that nobody's afraid of it. Nobody's saying, hey, that's not the way we do it. You can take your time. You can quote any equipment that you might need. So you can get 3 prices and buy it from the best, with the best price from the right guy, as opposed to just, getting the first one that the answers that can get it there the fastest. And you can ship it in. Say, what, put it on the slow truck. I don't need to overnight it. I don't need to bring it in. 2-day freight. Just put it on the next truck so that it gets there, and I can save a little money on that. And you can wait until the beginning of the month. And if you're a job shop supplier, you'll know what that means. That you do 80% of your business in the last 2 weeks of the month. So it's better to schedule it. Say, all right, you know what, May 1st or June 1st or July 1st. We're going to implement this change. We'll have the maintenance guys. We're going to shut down the line for a week, and we're going to do it right. We're not going to take any shortcuts. We'll do it when we don't impact our customers. So what this means is that if you implement all of these things, you're doing it on your terms, and your terms will always be cheaper and easier, and you'll sleep a little bit better at night. So, and going to the last slide, my last piece of advice is burn the boats. And by that I mean, after you've invested in this new technology, you've brought it in, if you keep the old tank there, like we're not going to get rid of the hex chrome until we're totally confident with the trichrome, what's going to happen is you're going to end up in the worst possible place where you're running 2 processes. You spent all that money, you implemented that change, maybe you told customers, maybe you told magazines, maybe you told your friends and neighbors, but the guys are going to fall back to what always worked. Whenever they run into trouble, whatever it may be, they're going to go back to the old way, because the old way is comfortable. They know it, they understand it, it's very forgiving, and they're going to gravitate to that every time. So once you implement this process and you're confident that it works and your supplier says it works, get rid of the other one, because they will always fall back on it. Every time there's a bump in the road, they will fall back on it. So in the end, if you implement the change for the better on your terms, you can save a lot of money. You can make more dollars. You can save valuable floor space. You can have less risk. I have 2 customers that will be cyanide-free by next month because we're changing some copper tanks for them, and they'll completely be out of it. So you'll have less risk, your employee exposure, and on and on. You can create a shopping list of all of the advantages that you get. So that's my presentation, and that's my perspective, and I appreciate the opportunity to talk, and thank you very much, Mark.
Well, thank you, Marco. And we do have a few questions, and we do have a few minutes to pose them. So the first one I want to do is see if we can explain a key term that both of you have used. And Chris, you are live and on the air. You mentioned it, RoHS, or as it's sometimes called ROS, the Restriction on Hazardous Substances from the European Union. If I could ask one of you to just describe what that is and how that's had an impact on the metal finishing business.
Marco,
Chris, let me ask you.
Okay, no problem. Yeah, the RoHS initiative was put in, like I said, years ago now. I'll say it probably got momentum probably about 10 years ago, probably was initiated 10 years ago or so. Maybe as early as 5 years ago is when it really started coming out. And basically what it does is it came up with a list of chemicals and or metals. It's an extensive list. You can see the list. There's a lot of things that you and I wouldn't or don't even know what they are. and it set numbers as far as parts per million of these parts being allowed in product that comes into their country, for example. It was set by the European Union, so whatever countries fall under that category apply. You know, that's what it applies to. And would, of course, we ship a lot of goods over to the European states and the countries over there, and so they're the ones who said, hey, we're not taking these articles in our goods anymore at this level, and that's a key part of that. Now, where that comes in, of course, is a very complex gray area, and somebody who is an expert in the field, who works at the European Union, would probably be able to tell you very specifically this, that, and the other thing. I cannot, but from our perspective, from somebody who has to deal with it on a daily basis, what it basically is it has set numbers, and so you have to meet these numbers, and ways to meet these numbers. Some of the major components on there was nickel is on there, which is a big problem right now, because there's a lot of debate going on in the industry about nickel. Nickel is a very widely used metal, and how does this apply? I mean, how can you, and it's not just nickel, it's all sorts of nickel compounds, sulfates, sulfonates, and chlorides, and how do you determine this? How is this determined? This is the long debate about this. This is why it's taking so long. So basically, from our perspective, it targets very certain metals and finishes, i.e. the, like I said, nickel and hexavalent chromates. I mean, those are two that are very prevalent in our industry. Other industries probably focus very highly on other articles that are on this list, you know, that don't affect us. Whatever, different manufacturing divisions and, you know, dry cleaning industry or whoever. I mean, these people might have other things that they have to be concerned about. This is what we are concerned about as metal finishers. So, so the goal is to reach these numbers, to satisfy the need for this, because the RoHS initiative is basically, now that large corporations are picking up with the RoHS initiative. Like I said, this has taken years and years and years. I mean, at first it was just a talking point, a fine-tuning point, a R&D point. Now they're getting to the point where, hey, you know, we have to be very conscious of this. I do not want this, this, and this at this level. And they're becoming more ways to test for it. I mean, that's what it is. I mean, they actually, there's technology out there where you could take a finished product and test all the elements in a part. You could just put it right on it and test all the different components of what makes up that part, and they can read these levels on these parts. So they're starting to really, it's gained a lot of momentum, and it's starting to become a reality. So people are being more conscious of it. It's coming down the line. Now, this person tells this person, that tells this person down the supply line, hey, you need to be RoHS compliant. Tell me that you are. And, you know, you have to do your research on it, figure out what components you are. It's not so simple as, oh, I have a certain thickness of nickel plating on my part, and so I'm out of compliance. It's not that easy. It's a very complicated process of how the parts are produced and what they use and the base metals. And so that's kind of a generalization of it. I hope it kind of makes sense. I'm sure you could go online or you know, go to, I'm sure they have a website. RoHS probably has a website where it will talk very specifically about technical terms, about what you know, what is involved in the different chemicals. But basically, there's a list. There's a list of chemicals and compounds on there that need attention in one way or another.
Yeah, Chris, let me just interject here. In fact, there are two European Union directives, the RoHS or RoS, the Restriction on Hazardous Substances, and also REACH, which is newer. REACH stands for the Registration, Evaluation, and Authorization of Chemicals. Right. RoS actually specifically deals with the electronics and electrical equipment industries, and has been around quite a bit longer, but that gave rise to REACH, and that is the the directive from the European Union that is currently having the greatest impact, not only on metal finishing industry, but on industries of all kinds, because of course anybody that makes anything has to use chemicals. So we here at the Toxic Use Reduction Institute can provide you with a lot of documentation and additional information should you need it. But I do want to go on to a second question that we have here, and let me pose this one to you, Marco. If a metal finishing company is looking to proactively start improving their environmental performance, such as you were suggesting there in your last couple of slides, where would you suggest they start? What should be the first thing they do?
Well, I may be kind of selfishly here, but I've always turned to the supplier because they're the folks that have the newest information, the latest and greatest. You have, I presume, a group of suppliers that you work with, and I would bring them in because those are the folks that are, typically selling worldwide, typically dealing with folks that are shipping worldwide, so they have to meet all of the specifications and requirements that are out there, and they're also the ones that are always trying to build a better mousetrap. So, that's where I think at least your first phone call should start.
Okay. Well, we've gotten here to the top of the hour, and that means we unfortunately have to stop. I want to just make one additional point of clarification because we did get a couple of questions coming in during the discussion here of RoHS and REACH. RoHS, which is the smaller, if you will, directive out of the European Union, it does apply to the electronics and electrical equipment manufacturers, and there is actually, with RoHS, a list of just 6 substances, a couple of types of brominated flame retardants, lead, mercury, and hexavalent chromium, and as well as cadmium. That's what applies to the electrical and electronics equipment industries. However, the new one that I mentioned, REACH, is the one that has this very extensive list of chemicals that are under review, and it, in fact, pretty much applies to any industrial chemical that's in use in any type of product. And so that's, in fact, what you need to look up. So you're probably more interested in REACH if you're interested in that broad, long list of chemicals. So we do need to bring it to an end here. I'd like to thank, of course, our 2 presenters, and thank you for sharing your time and your experience, Marco Duffy and Chris Capalbo. Very, very good. Again, our colleagues over there in New York State at the Rochester Institute of Technology, New York State Pollution Prevention Institute, and finally helping me with production here at Torrey Autumn Massey. So I hope you've all enjoyed it. You will be seeing an evaluation come through as we stop the webinar, and also on email. It would be very, very helpful if you filled that out for us. So again, thank you for joining us, and we will see you hopefully again.